Okay, so let's start discussing the tasks for the homework. Okay, so task number 1. Krista arranged her buttons in an array which 2 expressions can be used to find the total number of buttons. First of all, let us write the equation for that array, okay? So I'm reminding you we are counting this way and this way. So here we can see 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6, 7. So the equation here is 6 times 7. Now we need to choose which expressions can be the same. Okay, in every equation, we are looking for the same factor at the same place. Okay, so here I can see 6 at the first place, and here 6 at the first place. So I write 6, okay, and here I can see 7 plus 1 is going to be 8. So here we have 6 times 8, so this is not good. Again, I'm looking for the same factor at the same place. Here I can see 7 at the second place and 7 at the second place. Now I'm adding these, and here I can see that I have 6 times 7. And this is okay. This is what we need, yes? Okay, let's check the other. Can you see the same equation, the same factor at the same place? For example, here 4 and here 2. Not good. Here 4 and here 3. Not good. We don't have the same factor at the same place. This equation is not good at all. Just cross it out, okay? Okay, and check the last one in case. So here I can see 7 at the second place, 7 at the second place. I add this and I see 3 plus 4 is 7 times 7. This is also not good. So the only correct is this one. You checked, and this is okay. Some students can do this in their heads without this, without showing the same factor or adding. But this is for those who doesn't understand. Okay, now let's go to slide number 2, task number 2. Okay, choose yes or no to tell if the distributive property is being used. So distributive property is breaking apart. We remember distributive property is about breaking apart. So can we see here breaking apart the number? Yes, okay, so we can see 4 and 2 plus 3. Here you also can see 4 at the same place and 2 plus 3. So this is yes. Here you can see factor 2 and 4 plus 5. Here you can see the same factor 2 and 4 plus 5. Yes. Okay. Here we can see 2 by 3 plus 1. So this is not, you cannot see the same division like here. Okay, and the last one. You can see 7 and 5 minus 2. Here also you can see 7 and 5 minus 2. Yes. Okay, that's it. Now let's go to number 3. Number 3, Jeff makes the generalization, and I was teaching that generalization is like making a rule that 10's fact can be broken into 2 5's fact. Write an equation to test this generalization. So this is what do we do here. It's very easy peasy. Just number 1, you are writing any equation about multiplying by 10. Okay, so any number, choose any number. I choose it 7. I write 7 times 10. Okay, and you know that this is This equals 70 because we write 7 and 0. 70, okay? And now what we are doing, we are breaking the 10 apart and try to do the same. Check the generalization, okay? Now let's do like this. Break it apart. We are just checking. We are not solving the problem like this. So now, remember, what do? We multiply this number by the opposite one and this number by the opposite one. Now we write 7 times 5 equals 35. You know, counted by 5, 5, 10, 15, 20, 25, 30, 35, yes. Okay, and again, you show me 7 times 5. 5 equals 35. 35. And if you add together, we see 5 and 5, 10, 1 goes up. Now you have 1, 3, and 3, you have 7, the same. This is, you just showed that you tested, that the answer is the same. 10 and 5 breaking apart gives you the same answer. That's it. This is the example how to do this. Number 4. June broke apart large array into 3 and 4, 5 and 4. What was that big one? Okay, when we break apart large one into 2, then to make it again big, okay, we put 2 together. So here again, the answer is easy peasy. You just do like this. Okay, let me check the color. So here you need to put 2 small arrays together into large one again. So we do like this, 3 times 4 plus 5 times 4. Now again, the same factor at the same place is 4. And these 2 you add, so 3 plus 5 equals 8 times, and 4 is the same factor, you just leave it. So this is the large array. The large array is 8 times 4. That's it. Okay, which facts can you use to find 4 times 8? We are doing the same. We are doing the same. We are checking. So we have 4 times 8. One factor is 4, one factor is 8. Okay, so can you see here factor 4 in this one? No. Okay, here we can see factor 8 at the same place. Yes, here it's the second place here. Okay, 2 plus 2 equals 4. Yes, so do we have here 4 times 8? Yes. Yes. Okay, here do we have the same factor at the same place? No, here 2, here 1. Maybe here, no, here 2, here 4, and 8. So this is not good at all, not good at all. Okay, let's check this one. Do we have the same factor at the same place? Yes, we have 4 here at the first place and 4 here, the same. Now the other we add 5 plus 3, is it 8? Yes, so do we have 4? 4 times 8? Yes, we have. Now check the last one. Do we have the same factor at the same place? Yes, we have 8 here and 8 here, the same place. I mean, first factor or second, the same place, okay? Now 3 plus 1, is it 4? Yes, so do we have 4 times 8 here? Yes, we have. That's it. Okay, this is the Word problem, a bakery uses 3 cups of flour. For each loaf of bread, there are 3 loaves of bread on a tray. There are 6 trays on a cart. So how many cups of flour? 3 cups of flour per 3 loaves of bread per 3 arrays. This is our equation. We are multiplying all the numbers. And now use grouping, okay? Okay, 3 times 3 is going to be 9. And 9 times 6, you know the strategy. Tens minus ones. So you do, here you may write for yourself or show me that you know to do the 60 minus 6. And this is going to be 54. That's it. So 54 cups of flour. That's it. Number 7, find the number that makes the equation correct. Actually, we need to find the answer, yes? Find the answer. So you're just multiplying. 3 times 4 is going to be 12. And 3 times 4 is going to be 12. And 12 plus 12 is going to be 24. So if you write here 24, your equation is going to be correct. Number 8. Casey has 3 bags of baseballs. Each bag has 6 baseballs. So this is easy peasy. You're writing the equation 3 times 6. And here, if you have numbers 3 and 6, I want you to show me that you can break apart. We were learning how to break apart 3 into 2 and 1. And we were learning how to break apart 6 into 5 and 1. So choose any that you want, okay? Let's say I want to break apart 6 into 5 and 1. Now, again, don't forget that you're multiplying like this. 5 with 3 and then 1 with 3. Now, 5 times 3 is going to be 15. Okay, plus 1 times 3 is going to be 3. And together it's going to be 18. 18, and this is, don't forget to write 18. Okay, that's it. Number 9. Again, it's about breaking apart, how you understand breaking apart, okay? Because the topic was about this. So you see 6 times 4, and you see 7 times 5. And here you see these equations. You need to sort which goes where. Okay, so again, we are looking for the same factor at the same place. I have here 5, here 5, and 5 plus 2 is going to be 7. So I have here 7 times 5. So that means that this one goes here, but you need to write, okay? You need to write. I'm not writing. You are writing. Okay, check another one. We have the same factor for here. 1 and 5 is going to be 6. So you have 6 times 4. This one goes here. Okay. Next, let's check. 5 and 5. We have here 5 and 4 and 3 is going to be 7. Yes, so this one, 7 times 5 is going to be here. Okay, now let's check another one with another color. Again, we are looking for the same factor, 5 and 5, and here 1 and 6, 7. So this is here again, we have 7 times 5. It goes this way to this column. And the last one, we have 4 and 4 here. 3 plus 3 is going to be 6. So 6 times 4 goes this way. Actually, you need to copy, okay? I'm showing you the arrows. You are copying in this place. Okay. Let me stop. Let me stop the. Okay, next one. A farm stand has cherries on 2 shelves. So we are circling 2. Okay, we are circling 2 shelves. Each shelf has 4 boxes, and each box has 8 ounces of cherries. How many ounces of cherries are displayed in all together? So we were learning together means plus, but here together we are doing multiplication because multiplication is connected with addition. So, and our equation is 2 times 2 shells, we multiplied by 4 boxes and by 8 ounces. So 2 times 4 is going to be 8, and 8 times 8, I told you to learn by heart, is going to be 64. 64. Okay. Number 11. Amy arranged her counters into this array. What array can you see? You can see array 3 down. Down goes 3 times. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 9. Okay. What 2 facts could Amy use to write the equation for the array? 2 times 9 plus 1 times 9. 1 times 9. Why? Because I can see an array 3 times 9, and we are going to break apart that 3. We're going to break apart the 3 into 2 and 1. Here you're not writing the answer, just the question is about 2 facts. Okay. Part B. If Amy adds 1 more row of 9 counters, can she still use the facts you wrote in part A to find the total number? Explain why or why not. Okay. If we draw like this, 1, 2, so draw please, okay? You are showing that you add 1 more array, 1 more row of 9 counters. So we are drawing 9 more counters. Okay, and now can we use the facts 2 and 1? We are writing no. No. Why? Because, let me type here. No, because we have 4 rows and 4 can be broken apart into 2 and 2, not 2 and 1. Okay, so I'm not going to give you this task number 11 in the test. You just do it like homework and that's it. In the test, you're not going to write anything, just count and calculate. Okay, and the last task the last task is this one. Okay, so the last task. Let us read very carefully and underline some key facts, okay? So, Tim's family rented a canoe, okay, that word is pronounced like this, canoe, for 6 hours on Monday and 2 hours on Tuesday. How much money did they spend? So now we have a look at this data and we see that that canoe cost $7 each hour. So if you want, you may draw a bar diagram if you want, okay? So you draw how many hours? 1, 2, 3, 4, 5, 6 hours, and every hour they paid $7, and again $7, and again $7, and again $7, and 7 and 7. Okay, if you don't want to draw a picture, you may not draw a picture, but you need to understand that we are going to write the equation 6 times, because 6 hours, 7, okay? And solve that problem. And here, show me, please, breaking apart any number, 6 or 7. I choose to break apart 6. Okay, and again, I draw for myself not to forget what I'm multiplying. I'm multiplying 5 with 7 and then 1 with 7. So I'm writing 5 times 7 is going to be, using our fingers, 35. 35, okay? And 1 times 7 is going to be, using our identity property, is going to be 7. Okay, and together it's going to be 42. And again, 42 what? 42 cats, 42 dogs, 42 ice creams. No, so you should know that this is $42. And what is this money about? It's about Monday. So you just write for yourself that this was spent on Monday. Now, next we are reading about 2 hours on Tuesday. So we write equation number 2. Okay, this was our equation number 1. I used a lot of space. Okay, equation number 2 is going to be 2 hours, okay, paid $7 and $7. So the equation is 2 times 7, 2 times $7. I cannot write here, okay. Oh, it's going to be 14. Oh my God, 14. 14 also dollars spent on Tuesday. Now, equation number 3 is going to be that we are going to add those money together, okay? I'm writing here, sorry, I'm writing like this. Equation number 3, we are going to add that 42 plus that 14, okay? And again, remember from grade 2, ones and ones, 2 plus 4 is going to be 6. 4 and 1 is going to be 56. So this is our third equation, $56. So in this task, we are not just only circle the numbers and multiplying. We need clearly understand what goes where, okay? You see here we have 3 equations. Okay, so that's it. Thank you.